Assalamualaikum, my name is Muhammad Koyum bin Azhar.
Hi, my name is Nurul Karimisa Wahyuni binti Baharudin.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Faiz Amini bin Muhammad Jafri.
Hello, my name is Divardhan son of Nayan.
Today I will present to you about the introduction of Project 5. Finite state machine is a sequential logic with a fixed number of possible states and has multiple functions. Finite state machine used for creating sequential logic as well as a few computer programs. The application of finite state machine is used for logic circuit, firmware for a microcontroller, as a fence, as a traffic light, and many more. The advantage of finite state machine is it is flexible. The next one is it is easy to move from a significant abstract to a code execution. The disadvantage of finite state machine is the order of state conversion are inflexible. The other one is the implementation of use system using finite state machine is hard for managing without any idea of design. Thank you.
There are two types of finite state machine. First, Moe machine. Moe machine is the output depends on the function of present state only. Therefore, the output can be changed only on a clock edge. Second, Meili machine. Meili machine is the output depends on the function of present state and current input. Therefore, the output can be changed when the input change. Hani is trying to control the fan speed in her study room. There are 3 buttons available to control the fan speed, namely 0, 1 and reset. The button can press only once on a time. Assume the initial speed is starting from 0, 0, 0. The speed can be controlled from 1 to maximum speed of 5. When button 1 is pressed, the state will change 1 speed ahead. While if button 0 is pressed, the fan will operate at the previous speed. Unfortunately, if the reset button is pressed at any speed condition, the speed will reset to the initial state. We are using JK flip-flop to design the finite state machine controller for the fan speed and illustrate the circuit in multisim software.
I would like to present about the circuit simulation. The circuit that we design is from the result of Carnot map that we obtain the input and output state from the truth table before. The circuit are using 3 JK flip-flop, which mean have 8 states, but the question only asks for 5 states. The right side of the circuit JK flip-flop called as less significant bit, while the left side of the circuit JK flip-flop called as more significant bit. The logic gates connection are based from the result that we got from K-map. So basically the simulation start from the initial state, which is when the fan speed is at stop position. So when the forward button is pushed, the speed is increasing slowly from 1 to 5 state. Then when the reverse button being pushed, the speed is decreasing slowly from 5 back to the 1. Finally, when the reset button being pushed, it will return to the speed. It will return speed back to the initial state, which is stop the fan. So let we go through to the simulation. So if you can see the simulation here, the state is on stop, which is the reset button being pushed. If we push back the reset button, the state will go to the first state. So if we push the forward button, the state will slowly increasing from one to another. If you can see, if I push the forward button, the state 1 go to the state 2 and state 3, 4 and 5. If I push the reverse button, it will return back from 5 to the 4, 3, 2 and the first one. If I push the reset button, it will back to the initial state. Okay, that's all. Thank you.
Now I would like to talk about the conclusion. Okay, now about the reinforcing of the main idea. We obtain this problem solving idea by wall fan switch that can rotate from left to right. by controlling the voltage rate which exits through the resistor to the output. The motor helps the wall fan to rotate. The voltage that exits from the circuit connection is consistent, makes it easily to control the voltage flow which exits the motor, and another way that's an output, adding resistor with different resistance in every switch. This proves us the way of implementation is effective and functioning in the simulation. Finally, we able to control the fan speed. Okay, now I would like to talk generally about finite state machine. Okay, this is all about the finite state machine. Therefore, finally we can infer from the above knowledge that synchronous sequential circuits influence their states depending on the input for each positive or otherwise negative conversion of clock signal. This action can also be indicated in the form of graphical diagram known as state diagram. Another name for the sequential synchronous circuit is also known as finite state machine, and a short form of FSM. Thank you very much.